So now look at the next problem. So we need to find the minimum value of the objective function subjected to these three constraints. Remember one thing. So finding the minimum value of p subjected to these three constraints is nothing but finding the maximum value of minus p subjected to the same constraint. Okay, so I'm just converting this minimization problem into maximization. So just consider the maximization of minus p. So let us multiply throughout minus. So minus x plus 3y minus 2z subjected to the same constraint. We have to apply the simplex method. Okay, so again we have to balance the given constraints by slack variables s1, s2, s3. We have three constraints here, so we come across three slack variables, and all the slack variables are non-negative here. And let us consider the initial simplex table. So the first row is from the first constraint, the second row is from the second constraint, and third row is from the third constraint. And of course the delta row can be written by using the coefficients of the objective function. We have minus 1 here, let us write plus 1, plus 3, minus 3, and minus 2, and plus 2, right? So what we have to do here in the delta row, we have to identify the smallest negative number. So minus 3 is the only negative number here. So this is your pivotal column. And we need to identify the pivotal row. So by calculating the ratio, quantity by pivotal column element. So 7 by minus 1, we need to ignore this because we are looking for a smallest positive, right? So 12 by 4, 3, and 10 by 3, which is 3.3. Among these two numbers, these two positive numbers, the smallest positive number is 3. So this is your pivotal row. So the intersection of pivotal column and pivotal row is your pivotal element. The corresponding variable has to replace with this slack variable, right? So what is the next step? We need to make this 4 as 1. How can I make that 1? By dividing the entire row by 4. And we have to make the other elements in the pivotal column as 0. We have minus 1, we have to make them 0 by suitable row operation. We have 3 and minus 3, we have to make them 0. Remember, while doing that, we have to make use of either old pivotal row or new pivotal row only. Okay, so observe here. So we made this pivotal element as 1, and we made the other three elements as zeros by the row operations which is given here. Fine. Now again we have to identify the smallest negative number in the delta row. We have minus 1 by 2, right? So this is the smallest negative number. So this is your pivotal column, and look at the pivotal row. So how can you find that? So let us calculate the ratio of quantity by pivotal column element. 10 by 5 by 2, which is 4, and 3 by minus 1 by 2 which is minus 6. We have to ignore this row since we are looking for a smallest positive. And of course 1 by minus 5 by 2, which is again a negative number. We have to ignore these two rows. The only row which is having the positive ratio is first row. So this is your pivotal row. So the intersection of these two rows is 5 by 2. So 5 by 2 is the pivotal element. Now what is the next step? So we need to make look at the corresponding variable here, x. We have to replace that by we have to replace s1 by x. How can you make this 5 by 2 1? So we have to multiply the entire row by 2 by 5 so that it will be 1, and we have to make this minus 1 by 2 as 0, and minus 5 by 2 as 0, and minus 1 by 2 as 0. So that can be done in the next table. So this is the next table, right? So we did this row operations to get this table. And look at the delta row. All the entries are non-negative, therefore we arrived at optimum simplex table. And here x equal to 4, y equals to 5, and of course z is not there, so z equals to 0. And the maximum value of the objective function is minus p. The maximum value of minus p is 11. So as a consequence, the minimum value of p is minus 11 at the same entries. Thank you.